WatchDog is an interactive web app for people interested in exploring crime in the city of Toronto. The web app is useful to a wide variety of users, such as new homeowners trying to assess how safe a neighborhood is before buying, novice readers trying to avoid accident-prone roads, or just anyone curious about crime rates in their neighborhood. Our dataset is a combination of crime data from the Toronto Police Open Data and census data from the Toronto City Open Data. The raw data comes in the form of large CSV files that are difficult to work with. Therefore, we have created our own scripts to restructure the data into a useful format for both storage and presentation.
The sentence at the top filters the information in the cards below by crime type, for which we have crimes, bike thefts, and traffic incidents. Additionally, for crimes, we also have a filter for the major crime indicator. Then we have date, for which we have year or month, and location, for which we have citywide, neighborhood, and police division. By default, it is set to show all crimes citywide that happened in 2019, but you can click on any of the underlined phrases in it to change it. Click OK and your new search will update the cards below. All queries have similar cards with different data. At the very top is a collapsed card which holds a table. This table card provides the raw data from the query and is paginated and also filterable. Right below it, we have a heat map card showing the amount of crimes per time period. We can also interact with this card to refine our time range. Next, we have a summary card which shows the number of crimes per major crime indicator. We also have a cluster map for each individual crime location. We can zoom in on the cluster to break it up and see individual locations. Then we have a line chart which shows the number of crime per month if our date type is set to year, or day if our date type is set to month. We also have a few other charts such as the horizontal bar chart, a donut chart, and a pie chart for different types of data summaries. At the bottom of all of this, you'll notice a map of police divisions. This shows the amount of crimes per police division and where the police divisions are located. Additionally, users can provide an address and the application tells them the closest police division. Now for bike types and traffic incidents, we have the same cards, just different types of data, such as bike type or road condition in the summaries. Note that since it may be hard to view certain small numbers, you can click on a chart label to remove it. As mentioned previously, we can also use some of the other filters. For example, we can look at the robberies that happened in Rexdale Kipling in March 2018. We can also filter by police division instead. Now you'll notice that at the bottom right, we have this report a crime button. Users can fill this out to report a crime and update the database. We can now change our query to 2020 and we'll see the one crime that we just added. Now let's look at the last two more innovative and advanced features. First, we have Batman mode. This feature is an interactive how well do you know you're a city feature. The user can turn on Batman mode with the button at the top right. Once in Batman mode, the user has to guess the total number of crimes that occurred and the crimes per month or day for the selected query. Then, at the end, users can see their score for guessing both the data. This is a fun way for users to explore the data and challenge their friends.
The other feature is the Predefined Queries feature. If a user is not sure what they're looking for, they can use the toggle switch to use a predefined question and explore the data that way. Currently, we have 21 queries, but more can be added quite easily. There are many interesting queries here, such as what are the 3 most commonly stolen bike types? At what hour do most crimes occur? Is there a correlation between neighborhood employment and crime? What is the most common drive action taken in traffic accidents? What is the average cost of bikes stolen? Which neighborhood has the most number of traffic accidents? Which road surface conditions have the most accidents? These predefined queries have also been sped up by the creation of indexes. Without creating too many, we found the common columns that occurred and created 5 indexes. We saw improvements of query time from 2.4 seconds to 0.6 seconds.
Both the web application and the SQL database are hosted on Microsoft Azure. Azure App Services and MySQL are modern, scalable, efficient, and flexible. This setup is ideal and efficient for building a web app such as ours. Plus, Azure is a cheaper alternative than others. The backend is made up of Node.js and Express.js, from which API endpoints are exposed. This is what directly talks with the database. The frontend is a React application. The notable NPM packages used include the Semantic UI React library for UI components, the Mapbox API for the maps you see in the application, Chart.js and D3.js for the data presentation, and AG-Grid for the table. Thus, our web application code mostly consists of JavaScript. Members of our group have experience with Node.js and React, which gave us an excellent basis for our project. We now briefly look at the backend queries for each feature. Predefined queries have its own file where question numbers are matched to each query. Note that some endpoints return the result of multiple queries. The features for querying the data have their own API endpoint. Further, we use URL parameters to allow the user to filter the data as needed. This allows the user to come up with their own queries in real time. The report a crime feature is a bit more special. There are multiple queries that happen here. We first check if the time provided exists, and we can find a corresponding time. If we cannot, we create them. Then we create the new crime.
When working on the project, we divided the work based on strengths and at the same time, cross-worked at certain times to make sure everyone had exposure to the full application. The primary database designers were Vikram and Lukman, with Dhvani being secondary. Therefore, these guys worked on the ER diagram and led the design of the tables. Afterwards, they primarily helped write the SQL queries, though everyone had an almost equal part in those. The primary data scientists were Abdullah and Vikram, with Lukman being secondary. These guys created the scripts to transform the raw data into the CSV files we needed. This was quite a challenging task as the data wasn't always clean. They prepped both the sample dataset and the production one. The primary application developers were Dhvani and Chandana, with Abdullah being secondary. They were the ones to investigate the best choices for deploying the app and which tech stack to use. Chandana also came up with the Figma design, and Dhvani helped translate it into the front end and back end code.
WatchDog is an interactive crime data application that has many uses. Working on this project has been quite a rewarding and challenging experience, and we hope you liked it. Thanks.